So in this video, we'll quickly talk about eccentricity. So related to, of course, eccentricity is related to elliptical orbit. So let's kind of draw an elliptical orbit right now. And let's draw an imaginary sun. Now when you have an elliptical orbit, your planet is going to be a quote-unquote focal point. Now a focal point is like a, I guess you could say it's a geometrical term. You don't need to know that. You just need to know that your planet that's being orbited around the sun in this case is a focal point. And the other side, if you mirror this, the distance between the sun and this focal point, same side, you get another focal point here. And it's just, well, I technically drew this bad, but it's just the mirrored distance between the center and the sun. So both of these distances between the center of this ellipse and the sun is called c. So it's called the variable c, and the distance from the outer edge, so the longer edge of the ellipse, and the center is called a. You can calculate eccentricity by dividing c by a. That is all. That is eccentricity. Now, let me show you what this number really means. Okay, so you have a c, and you have an a value. If you divide that, you get eccentricity, right? What if this c value, what if this planet was getting less and less elliptical? So let's say there's this kind of elliptical orbit here. So as you can tell, this is not an actual circle. This is kind of elliptical, but the sun is super close to the center of this orbit. Well, if the sun is super close, the distance between the focal point, or the sun, and the center is c, and that's going to be very small. And this distance between the center and the outer longer edge of this elliptical orbit is a. So if you divide c by a here, you're going to get a very small number because c is a super small number. Now, what if this approaches a circular orbit? So let's say this is a circular orbit and the sun is right in the middle. Well, if the sun was right in the middle, there's no distance between the sun and the center, or a focal point and the center. Therefore, c in this case would equal 0. So if c is equal to 0, then no matter what a is, so maybe a would still be the distance between the center and the outer edge, e would equal 0 over a, which is equal to 0. So if your eccentricity is equal to 0, then you have a perfectly circular orbit. But if your eccentricity is a larger and larger number, then you're going to have a more elliptical orbit. So eccentricity, all in all, just describes how elliptical something is. And if you approach 0, then you are perfectly circular. So, as always, if you have any questions, put it down in the comment section. Hope this video helped.